Just like with fractions of numbers, adding and subtracting fractions of polynomials is actually more difficult than multiplying or dividing them. Let's see how we do this. First, let's look at a simple case of adding rational expressions. Say we have x plus 1 divided by x plus x plus 2 over minus 2x. Notice that x and minus 2x are like terms, so this is actually easier than most cases. If we multiply the first term on both the top and bottom by 2, we can get 2x plus 2 over 2x minus x plus 2 over 2x, since the minus sign in the denominator of the second term can be carried out. Now that these two terms have a common denominator, we can simply subtract the numerators and divide it by the common denominator. So we have 2x plus 2 minus x plus 2 divided by 2x. Now if we simplify the numerator, one x will cancel and we'll be left with x and 2 minus 2, which is 0. So just x in the numerator divided by 2x. Now just like other operations with rational expressions, we need to simplify our answer at the end. So there's an x in the numerator and denominator, which both cancel, leaving us with 1/2. Now let's consider the general case. Suppose we have z minus 1 over z plus 1 plus 6 over z squared. These denominators are not like. So just like with adding normal fractions, we want to find the least common denominator. That is, the simplest polynomial that both denominators divide. In this case, it's clear that z plus 1 and z squared don't share any common factors, which means that the least common denominator is going to be their product. So we're going to want to multiply both the top and bottom of each of these expressions by the appropriate polynomial so that they share this common denominator. So let's multiply z squared to the top and bottom of z minus 1 over z plus 1. And similarly, multiply z plus 1 to the top and bottom of 6 over z squared. We can do this since it's equivalent to multiplying each of these fractions by 1. Notice that by doing this, the denominator of both of these terms are now the same, which is z squared times z plus 1. So we can add them just like we can add rational expressions that have like denominators. So we get z squared times z minus 1 plus z plus 1 times 6 divided by the common denominator, z squared times z plus 1. Now let's simplify. First let's do the numerator. Z squared times z minus 1 is z cubed minus z squared, and z plus 1 times 6 will give us 6z plus 6. And the denominator is still z squared times z plus 1. Now the reason I haven't simplified the denominator yet is that we want to check to make sure the numerator and denominator don't share any common factors, so leaving the denominator in a factored form is helpful. Now the numerator is not divisible by z, or z squared, since it has a term 6 at the end which doesn't have any z's in it. To find that the numerator here is not divisible by z plus 1, we can simply do long division, but I won't do that here. And finally, we see that the numerator and denominator don't share any common factors, so we can write the denominator out using the distributive property. So we'll get z cubed minus z squared plus 6z plus 6 divided by z cubed plus z squared, and that's the final answer.